And to get you started and get you thinking, let's take a look at our problem of the day. Problem of the day from Mathline. Here we go. If the diagonal of a rectangle measures 13 inches and the width is 5 inches, we're going to find the area of the rectangle. Let's look at that one more time. If we have a rectangle, by the way, we all know what a rectangle looks like. Let's go ahead and see if we can create one here. We have a good problem right here. The idea was that we are looking for the area of this rectangle, all right? We do know a couple of things about it. We know there's a diagonal, and we need to draw in that diagonal also, all right? So here we go. I tell you, when paper slips, it slips. That's what happened. Let's see, put that right through there. There's the diagonal. Beautiful. And in what we've created a right triangle going on here. And we were told that diagonal was at 13 inches, I believe. And the width, we'll call it this little short piece right here, was 5 inches. We're trying to find the area of this rectangle, my friends. That was the storyline on this one. So just kind of had a few little botches and spills here. So what's needed is what's going on here? Because in order to do area of a rectangle, its area equals base times height. Base times height. Sometimes length times width, base times altitude, all sorts of different ways. We like to call this the width. We call this the length. We could also call this the height at the base. It's just semantics, all right? Just nice little letters and variables and what have you. So let's go for it. We're going to look for the base times the height, but we need to figure out what we're going to do. Now, I did allude to the fact it's a rectangle, and that's the only way this is going to work. We have right angles going on there, which make right triangles, which make Pythagorean Theorem happen, all right? So let's do that. Let's figure out what this question mark is. I'm going to call it B for lack of anything better. Sometimes that's what we do when we call it B in the right triangle business and use the Pythagorean Theorem, which, by the way, some of you keep saying, Ernie, what's the Pythagorean Theorem? Well, let's look at it. It's A squared plus B squared equals to C squared. I was about to put C in there. Our C is always the hypotenuse, by the way. So there's C. And this is A right there, okay? So that's our story. We've got to figure out what B is. Well, if we know A and C, it's always easy to find that third variable. So let's put it in there. 5 squared plus B squared equals to 13 squared. We're on a road now. We're on a roll, in fact. Everything's working good. We've got 5 squared, which gives us 25. We have this B squared, which we don't know, but we're going to figure it out in just a second. Go ahead and drop my lower third down there, guys. That'll be fine. And I've got 169 because I know what 13 times 13 gives. How much do you all do also? That's what 13 squared is 169. Get those things kicking, those perfect squares in your head. This one was chosen for a good reason. We lose the 25. We'll subtract it from both sides. And we've got B squared on the left. And on the right, we've got 144. And here we go. Time to take a square root. And you know what? We're going to go with 12 because 144 is a perfect square. Now you say, Ernie, why did we need to square root? Because that's how we get rid of B squared. We want B. We don't want the squared part. So to basically unwind that part, we've got to do the square root, all right? And if we do it to the left, guess what? We got to do it to the right. So we square root 144. We were very fortunate. That's why I said good numbers here that it comes out even. So let's go ahead and put the 12 right there. And we're ready to say, by the way, that's inches. Now we're ready to multiply. We're going to take 5 times 12, and by the way, I got those vice versa. I know it'd be 12 times 5, but you know, it's commutative property, so you're okay. You're all right. But what's going to happen? Well, we're going to get 60, and we are going to have square inches from this result on, okay? And that, folks, is where we get you through problem of the day, all right?